analysis equipment for the mining industry, and the analyzers that we sell are used 24/7. So there are also service agreements and spare parts and all that comes after the initial sales. Our customers typically need to analyze slurry, or could be processed water, or electrolytes, or leaching solutions to quantify the metal contents in the slurry or solution, and using those numbers to optimize the concentration process. The analyzers that we sell are based on Xore equipment from world-leading manufacturers. We have our own software that runs on a PC that does the analysis. So it's a competent, high performance and flexible system. Like I was mentioning, there is a couple of different applications for the analyzers. They've been used on slurry for a very long time. The applications that are perhaps less known but still quite well proven is, for instance, on electrolyte, where in a copper smelter the analyzer is used to quantify the copper contents in the sulfuric acid, and they are using that to control a certain part of the process. It's been used in 14 years, and it's the same analyzer that's been there the whole time, so I guess it's a testament of its durability and construction. Since we also have really low detection limits on the elements that we analyze, it can also be used to monitor processed water, where you may still have some metal content that needs to be removed before the processed water is either recirculated and reused, or it's released back into the ocean or into a river and so on. So you need to maintain the high quality environmental standards that all companies need to live up to these days. We also have, since 3 years back, an installation that's measuring gold and tellurium content in a cyanide leaching solution. And again, it's an interesting application because of its quite the wear and tear on the parts is going to be really high, so we need to take care to choosing every little component to be able to do these analyzers. And again, like in the electrolyte, it's a hostile environment, but our analyzers are actually quite well equipped to do these things. These are the elements that we can analyze, from potassium to uranium. This is how our analyzer sees the sample. We use energy dispersive XRF, which means that we have an X-ray tube that excites the sample, and each element is sending back a photon with its specific radiation. The detector sees this, and it counts the photons, and it builds this spectrum. This is from a Swedish zinc and lead ore. So we use the height of the peaks to compute the metal contents. That's basically how it works. And you can also see, for instance, that with silver we have super low detection limits. This is only 0.0015% silver, but you can still see that there's a noticeable hump in the curve, so we can definitely see that there is silver there. There is also a bit of copper, there's a bit of manganese and so on. So this is kind of how the analyzer sees the sample and how we compute the levels of metal in the sample. We have two products. They share the same X-ray tube detector and so on, so they don't differ in measurement performance. The difference is in how the samples are handled. The Xore 24 here has 24 measurement cells, so we can do 24 different streams without them ever sharing a tube or a path or anything. So there's no chance of cross-contamination between the samples. And this is unique. And this also makes it possible to keep a really high measurement rate. And that is something that I will emphasize a bit more in the coming slides. The rate of measurement is going to be, I think, become even more critical in the future. The Xore Compact here can do 16 different measurement streams. It has 2 measurement cells, which means that you can have 8 samples going into one measurement cell, and you can have 8 more samples going into the other measurement cell. And having 2 measurement cells still gives you the advantage of not having to mix your high-grade samples with your low-grade samples, as is the case with some of our competitors. And also having several measurement cells gives you a bit of redundancy, and it also makes it possible also for the Xore Compact to have some sort of overlap in the measurement sequence to speed things up a bit. So while you're measuring one sample, you're preparing the next sample already in the other measurement cell. So that's how we save time on the measurement cycle. And again, time is going to become more and more critical as the mining companies. You can read on many mining companies' web pages that they've invested in really high specification control systems. Now, the on-stream analyzer is the tool they have to put data into their control system. So that's why you need to make sure that your analyzer is not going to be a bottleneck. So the on-stream analyzer is the most important data source actually to these control algorithms. Analyzer accuracy is, of course, is an evident parameter to take into account. You want good, reliable measurements. But analyzer speed is going to be even more important in the future. And of course, you're going to want the same accuracy. You're not prepared to sacrifice accuracy for speed still. You want the same or better accuracy, but at a higher rate. And the Xore analyzers, both of our analyzers, the Xore Compact is maybe double the speed as the competitors, and the Xore 24 is about 3 times faster. So there's a significant increase in performance there choosing our analyzer. So this is an illustration of why speed is important. If you make 3 measurements, this is what you're gonna get. You have an indication of what's going on, but not so much in between. So if we say if we make 3 times faster analysis, you get a different picture of what's going to happen. And the truth is somewhere in even more complicated perhaps. But this is just to make it clear to just about anyone that speed is going to be important, because if you maintain this level, you might not know that the rate of the level of copper or what you're analyzing is increasing. So you think it's here, but it's actually here. So you're losing efficiency the whole time. So keeping a quicker sample interval is going to give you a better view of what's happening right now, of course. So what sample rate do you think you need? Well, let's say a flotation tank in a concentrator plant has about 15 minutes settling time. This is it's not a made-up figure. It's a reasonable figure. So, according to really simple sample theory, you need to sample at about double the speed as to what you're measuring. So if you want to measure a 15-minute change, you're going to want to have 7.5 minutes sample interval, or even quicker maybe, to avoid that you're going to lose track of the rate of change there. So for one sample, that's not difficult to have 7.5 minutes measurement time. But if you're going to look at a full analyzer system with 24 measurement streams, which we have then for the Xore 24, you're only going to be allowed about 19 seconds per sample if you're going to do the full turn of 24 samples in 7.5 minutes. Or if we choose a smaller system with 16 sample streams, you're going to be allowed a little less than half a minute per sample stream to have the full sequence done in 7.5 minutes. And this is not something that our competitors can do. They quote in their data sheets about 1 to 5 minutes in analysis time per sample stream, right? And we have about 20 seconds for the Xore 24 and about 30 seconds for the Xore Compact. So someone might say now that, well, we have one of these slower analyzers, but we'll just stick in an extra measurement of the stream that we're interested in here on the flotation tank, for instance. So we won't lose any time, really, right? No, you won't. You will not actually just lose one sample interval, given that our analyzer is already 3 times faster, right? So you're gonna lose not one sample, but you're gonna lose 3. And this is an attempt to illustrate what's happening here. So the red line here is the measurement sequence for the Xore 24. It goes from stream number 1 up to 24, and then it starts back at 1. So this is the really simple sequence. And you can see that, well, if we put in an extra measurement on the slower analyzer here, you're going to start at number 1, and then you're going to go up to somewhere about 9 maybe. Then you're going to have to do number 1 again to keep the same rate as the Xore 24. And then you go back to 8 or something, and you continue going up, and so on. And then you need to go back to number 1 to do the measurement to keep the same speed on that specific measurement, right? So what you can see here, that almost 30 minutes later, the slower analyzer has made its all the way from stream number 1 to 24. And in the meantime, the Xore 24 has done a little more than 3 full turns of the same sequence. So if you want to build a control algorithm that uses data, you may not, due to the natural variations in the sample, and from the grinding and from the mills and from all the other things that happen in a concentrator plant, you're not going to just use one sample and use that for control. You're going to use a couple samples and make an average out of a few samples and use that to go into your control system. So here you have 3 samples in a little less than half an hour. But here, with a slower analyzer, you're just going to have 1 sample on 3 samples from one stream, and the other ones you only have 1 sample to go with. So you're going to take another full 1.5 hours to get 3 samples from this stream, number 10 or something. So you will quite quickly lose speed quicker than you think. And if we're looking at having 2 streams measured at the same time with both analyzers, so now they're analyzing stream number 1 and 13 at the same time, you're going to see that by the time the slower analyzer has made it all the way through the sequence, measuring all the streams except 1 and 13 is measured twice as often, the Xore 24 is almost completing its 4th cycle in the same time. So this is something that really needs to be taken into account already today if you're looking at upgrading your control system in the future, because analyzers are quite pricey equipment, so you don't want to spend your money today buying something that's not going to reach your specification tomorrow. So there are a couple of benefits that you'll have regardless if you're using a fancy control system or if you're just using it as most are today, more or less by hand and by the experience of the operators. With a quicker sample interval, you're going to see trends earlier, and using that you'll be able to predict the process behavior better. And of course you will see these short-lived variations that you would otherwise just be blank. And then of course in the future you're going to be better off, because with more data points, a larger data set, you will be able to build better control algorithms. And then when you're using these algorithms, with more data going into the algorithm itself is going to give you a better result at the end. So more data is better. There's no doubt about that. So again, these are the things that we need to take into account already today, so you won't have to make an investment first now and then another one to meet your specifications tomorrow. You have the tool already to be future proof. Okay, thank you very much. Again then, I'm Mikael Normark, CEO of Xore. Thank you very much.